All right. So, hello everyone. This is Dinesh again. This will be lecture 4 of this tutorial on R programming, and we will look into graphics today, different kind of plots. I'll give simple examples to give you an idea that how plotting works in R. And once you get this basic idea, I'm pretty sure you can start optimizing the plots by playing with different parameter settings. So for graphics and plots in R, you need data frames. This is a third type of structure in a data object in R. So a data frame is a two-dimensional data object. So remember, we have vector, which means it's one dimension. It's either a row or a column. But when you have a data frame, you basically have rows and column like an Excel sheet. And so you could say that a data frame in R is sort of an Excel table. And so let's create some example data that we can use for checking different functions that can be applied on data frames. So this is J1. It's a vector of randomly selected 30 numbers from a range of 100 to 200. J2, it's another vector, 30 elements, range of 100 to 200. Then we have a vector K, that is a repetition of 3 classes, class 1, class 2, and class 3, each 10 times. Then we have male and female value repeated 30 times. Now, in order to make a data frame, you use a function called data.frame, and that function tells R to take the input vector list and put them next to each other to make a table. So it's sort of like putting columns next to each other. So if I run this one, it's a df1 data frame, and take these 4 vectors. Now the rule here is that all 4 vectors should have same length. So if you look at here in the environment, that they all have 30 elements. So J1, J2, K, and L vectors, they all have 30, 30, 30 elements. So you need to have exactly the same length for all the vectors that you want to combine into a data frame. R will throw an error, or it will complain that if any of the vector had the size or length does not match to the rest of the vectors. Now when you do this command, R will basically put the column names exactly the same as the vector names. So we had a vector name J1, J2, K, and L, and R will put those names as a column names. Now if you want to change the column names, that I don't like J1, J2, K, and L, we want to have a little more specific, then you use this assignment operator, and you can say that variable 1 is J1, var 2 is J2, class is K, gender is L. So this is how you get column names in a data frame. So now your data frame has different names. So you can change these names for data frame when you're creating a data frame. Now there is a command and there is a function which will allow you to update these names. Yes, I have it here, so I'll explain it. So that's how we create a data frame, that you need vectors more than one of same length and R will put them next to each other, like you do in an Excel, putting columns next to each other. We will make other data frame, but little slightly different data numbers. So instead of using 100 to 200 range, I'm using 150 to 250. So create J1, J2, and I'm creating a class vector, but instead of using 1, 2, 3, I'm using class 4, class 5, and class 6. Just a variation, so you can see that when we combine data frame 1 to 2, how it looks. And then we will make a data frame 3. Data frame 3. Okay. So now we have a other data frame called df3, and it has it has exactly the same column names, but some values are different, like class column has different values and variable 1 and 2 has a different values. So these are key functions now, key functions for data frames. Now you want to know how many rows we have in my data frame. Then this command is number of rows, and it will give you that yes, it's 30, because we created 30 30 entries. Number of columns, df3, we get 4 columns. Now these two functions are more helpful when you're importing data and you want to know about the dimension of that, how many variables I have in my imported data, or how many cases or variables I have in total, like number of rows and number of columns. Since we created the data, so it's kind of, we know that we have 4 and 30. Names will return column names. I'll remove this guy. So names will return that what are the column names. So you have variable 1, 2, class and gender. If you want to change names, then we provide another vector and we say 1, 2, we'll call it class K, and we keep gender. So that's how you change the names of a data frame, that provide another vector with names in it. So they have all quotation mark around it, and it has to be same size. So if you have 4 columns, you need to provide 4 values. So I'm changing class to class K, and now if you run names 3 command, then you can see that it has changed from class to class K. Let's change it back. So okay, so that's how you change names. Changing names is really helpful because these names will be used by plotting packages and plotting functions on x-axis or y-axis. So these are default names, and this is also helpful because many times you import the data and there is a hard coding of variable names, and you may want to change it for a bit more intuitive or understandable names. So that's how you change it, that you provide a vector, other vector of column names, and use this function names and put as data frame, and it will R will change the column names for that data frame. Now command head, keep calling commands here. These are functions. So function head basically shows only top 5 or 6 rows in a data frame. This is helpful when you import a really large table and you don't want to display the whole data table in this console. That will crash R. So if you just want to look at the top part of a data frame to get an idea about how, if the data were imported correct or if the column names were correct, you can use the command head and it will show only the first few rows in the console here. So row names, that if you have provided row names to the data frame, it will show it, and if it didn't, since we did not provide row names, so it will give just the numbers, that all of our row names are numbers like number 1 to 30. But if you provide a second vector having exactly 30 words in it, and if we say row names assignment vector and that vector with assignment operator with that vector with 30 names, R will update row names by this function. And so column names are similar to names, that we have these 4 words as column names. So column names and names are sort of same. Now let's cover factor. So this is a special type of derivative data type. By derivative, I means that when you have categorical variable in your data, for example, we have male and female DF3. Yeah, we have male and female in the gender column. Now, when you think about, like, you may want to make a box and whisker plot. So you want to tell R that take all the data that has male in the gender column and then take all the data that has female in gender column, then make a box and whisker plot, or do a error bar on it, or calculate standard deviation and plot it on a box and whisker plot. And in order to do that, we need to tell R that treat gender as a categorical or factor response or factor column. Now there are new packages that will do it for you. So even if you don't define this column gender as a factor, the new packages coming today, they will understand that yes, you want to use the gender column as a factor, as a categorical variable. So in order to convert gender to a factor variable, you need to use the command as factor, and we provide gender. Okay. So as factor will convert a character response, or if you have numbers, it will convert numbers to a character. So as factor command will convert a character vector or numerical vector into factors, and factors allow you to group data. By grouping, you mean that, for example, in a box and whisker plot, or if you make an error plot with mean or error bars. You need to do the same for DF3. Okay. So that is, so far we covered importing, creating a data frame, then look in the top rows and check in the column names, changing the column names, and how do we convert a character variable into a factor variable. Now next part is subsetting and indexing. Then how do I get a specific value in a data frame out? And so in subsetting, R has a universal rule that if you, as long as you using square bracket, you are basically accessing as a data inside a data object with the location, names, or booleans. Remember, that's coming from the explanation of about vectors. So same thing with data frames, but you need to give rows and columns. So rows are always first and then columns are second, and there is a comma in between. So left side of the comma is the row number and right side of a comma is a column number. So for example, if I want to have value of row number 1 and column number 1, so that would be row 1 and column 1. It will give me value 197, which we can check my head df3. So this is the value 197, which is located at row number 1 and column number 1. And you can use the same trick we learned for vectors, that you can provide, instead of providing one row, you can provide a vector of locations. So instead of having one row, I can have like row number 1, row number 3, row number 5, and then I will get those values. That row number 1 has 197, 193, and 220. So 190, 193, and 220. So you can create a vector of rows that you are interested in. Now you're wondering like, okay, how do I use it? How do I get these locations? So let's ask a question to this data frame 3, that give me all the rows that has a value male in the gender column. So we want to have those row numbers. And remember the command from vector yesterday, that will be which command. So we can say that which df3 $gender is equal to male. So this command should give you the location of all the rows that has value male in the gender column in data frame 3. So which of df3 data frame gender column are equal to male value. And now we can use this vector output right here. So actually I'll type it again. And first column. So what are we doing? We're saying that I am not interested in all the rows. I'm interested in rows only where gender is equal to male, and I'm interested in column 1. Now if you remove column 1, then okay, can I get all the columns back? Then you can just remove it and leave it empty. So after the comma, if you don't put any value, R will interpret that you are interested in all the columns. And then you will get all the columns. So now you can see that we're getting a data frame back for all the value for column gender where value is male. And what I usually do, I actually store it by intuitive name, and we can call it male. So I just save this smaller data frame as a df3.male, and so this is a subset data frame of df3, and but it's only values where gender column has male value in it. Okay, so that's how basically you subset a data frame. Now you can think about different combinations here, that which command is actually flexible. So I can actually put and here, and I can say that, oh, I'm actually interested in male, and I'm interested in where my class is class 4. So then you will get a further smaller data frame. So this one where we have all the classes, class 4 to class 6, and we filter it again that now I'm not interested in class 5 and 6, I'm interested only in class 4. Then you get class 4 values here. So that's how basically in simple way subsetting work, that you create these vectors of locations. So these are the vectors of locations. Then you provide them either as a row selection before the comma, or you provide them after the comma as a columns. So, and creating these location variable vectors, you have three options. You can provide the exact location numbers, you can provide the names, and you can provide the logicals like true and false. So I just gave an example of exact locations that I type in, or I got from the which command, that where gender is male and class is 4. Several times you need to do transposing. In Excel, that's exactly the same, that you basically convert rows to column and columns to rows. And in R, that's a simple function called T, and T means transpose. And if you transpose, it's basically convert a data frame into a matrix, and it will convert that table of 30 rows to another table of 30 columns and four rows. So now rows have names, variable 1, 2, class, and gender, and columns. In this case, columns don't have a name because we did not have row names in the DF3 data frame. So, and this is helpful when you have some functions. For example, if you're doing PCA, and if you want to create a PCA of variables or PCA of samples, just by using the T, you can switch it. Combining data frame. Combine DFs. So the next function is called rbind and cbind. These are combining functions, like you combining two data frames together. So rbind means by rows, and cbind means by columns. And for rbinds, column names or names must match. Names must match. So, and the simple example here would be, let's create dot class 4. So this was in class 5. So I have these two smaller data frames. df.male.class4 is basically smaller data frame where gender column has male values and class has class 4 values. And then this other one where class has class 5 values. Okay. So now if we want to combine these two by rows, rbind, and we say df3 And RStudio make it easy that you don't need to type the whole name of the data frame. It will just display it, and all you have to do is scroll down, you press a tab, and df3 class 5, yes. So RBind will first check if column names are matching. For these two examples, smaller data frame, it did, because we had variable 1 to class and gender and variable 1 to class and gender. If column names are matching, it will just put them on top of each other. So it will take the class 4 data frame and then just put on top of class 5. And now you can see that you can combine as many data frame as many you want. So if I put this class 5 is a third data frame, it will just repeat it again. So now we have from that this class 5 values again, because we have a third data frame. This is helpful or useful for several plotting functions, where if you have multiple groups or you combining data from two experiments and plotting them together. So you need to import data from experiment 1, for example, and experiment 2, and then you can combine them together, make other data frame, and then use that one as a plotting function, and then those functions will understand that, yeah, the data come from two experiment, and we need to combine the plots. Now, I would recommend doing this binding of data frames in Excel. So where you can put all the data from different experiments together and just using the read Excel command to import it. Because it will be easier when you're starting the code. So if you have this kind of situation, so you have a one experiment up to here and second experiment is here, use Excel to put them next to each other, and then you can use the readXLS file to import the data frame. But if you're making data or you're making dynamic data in R code, that's how you combine them. CBind will take two data frame, and then instead of putting them on top of each other, it will put them besides. So we know our DF2 and DF3 data frames, they both have 30 rows. So for CBind, the row numbers should be exactly the same. So now what happened is that it takes the DF2 data frame, which is from here to here, and then it takes the DF3 data frame from here to here, and it will put next to each other. Now CBind doesn't care about column names should match or not, because you're just putting them next to each other. So this is helpful when you're combining different type of data on same sample. For example, if you have metabolomics data and you got some other clinical data or transcriptomics data, so you can think of that you have a data frame of assay 1, data frame of assay 2, data frame of questionnaires, data frame of other measurements, and they all have exactly the same rows and the same order the samples were. Then you can use the CBind command to combine them together. I'll put a note, names should not need to be same. $sign allows you to access column by names. So you have DF3, and if you just want to have what are the values in the gender column, then you use $sign. This is helpful because many times we don't know the location of columns in a larger table. So if you're handling, let's say, 500 variables, then it will be hard to scroll through on a screen that exactly what number has variable X. And that's why you can use the dollar sign, and then dollar sign will then just go like, okay, gender is located at somewhere in the table. You don't need to worry about the exact location. You can access the columns by names. All right, so up to this point we covered how do we generate data, a data frame in R, then how do we subset it, provide column names, then we can have a smaller data frame and combine them together by either by rows or by columns. Now, often you need to sort the data frame, and sorting a data frame is exactly the same as sorting a vector, but you need to select that which column should be used for the sorting. And so let's say we want to sort the data frame by variable 1. So this is a variable 1, and I want to sort the entire data frame by first sorting this column and then sort the entire data frame. So to do that, you need to first get the order. So, yes, this one. So, order command, remember I told you that it doesn't give you the values back, but it gives you the location that which value in the input vector should be at the first, second, third, and so on locations. So these are the locations. So now it's exactly the same way that in order to sort a data frame, you need to provide the location of rows and then leave blank after a comma. So you have df3, and I want all the rows but in this order, and I want all the columns. Then what it will do, it will just get you a data frame, but the rows were ordered by the sorting order that we have based on variable 1. So now if you can say variable instead of variable 1, I can have class, class is actually sorted, so we can have gender. And then it will sort by gender, that it pull female first and then male. So that's how sorting work. That it's actually a subsetting, but instead of doing you making it smaller, you just reordering. So basically providing the row locations in this square brackets. So here you learn that inside the square bracket, the row names, which is before the comma, you can actually provide 1, 3, 5 up to the total row number, but at different orders too. So that way you can reorder your data frame in several ways. And after the comma, it's a column value, so you can have the location of the column, or you can have column names, or if you have logicals like true and false as a vector. All right. This was all in R when you're doing data frame creation, sorting, order, combining, and everything. But we are more used to Excel. These are rather easy to do in Excel, that you can sort just by couple of clicks. You can sort, you can combine, you can just copy and paste stuff in Excel. I recommend doing it, that if you are more handy with Excel and like doing manipulating data in Excel, then it's better to do in Excel than just import it. And to import the Excel data, we have this package called read Excel, and the command is read Excel SX, and then you provide the file name and then data sheet. Now you can think of this way, that for one experiment you can have several sheets in that Excel file, and each sheet have some different input. Like you can have an input for bar chart, you can have an input for box and whisker plot, you have input for PCA, you have input for statistics, and so on. So you can have one gigantic Excel sheets with different type of inputs in each sheet, and then you can start importing that each individual sheet using this package. That makes it really easy, because then you don't need to do this lot of data formatting and sorting and ordering in R. You can do all that in Excel and put them into different sheets and just directly import in R. So for example, I'm importing CDF, which is data dictionary, NDF, data matrix, and SDF is a sample metadata. So if you're having hard time like arranging this data, I would recommend go straight in Excel, do it, and just import Excel data directly in R. That was importing in Excel. You can also import a text file that has default tab delimited. So this is the file here, this one. So this is a text file, and the delimiter is a tab. R can import it, and this function known as read.delim, which is intuitive, that we're going to read a delimited data file. That is the name of the file, and headers are true, which means the first row is the column names, and strings as factor is false, that by default do not convert characters into factors. This is important when you're importing tab limited files, that you don't want R to convert your character vectors into factor by default. It will cause trouble. So whenever you import tab delimited data, try to keep it false, string as factor as false. Okay, so now we will go into plotting functions. So that was all about data frames. I think I covered most of the key functions, but the overall message is that if you like transforming, if you like formatting, ordering in R, that's great. If you can learn it, and you will need it all the time. But if you are just a starting and beginner, you're having hard time reformatting it or sorting and ordering, I would recommend go straight with Excel, create a sheet inside it with exactly how you need to format the data, and then import it. That will make it easier to get data directly into R, and then you can start using it. All right, so now we will look into plotting different kind of plots that we can generate with a package known as ggpub-r. I recommend using ggpub-r because it's basically utilizing the same functions in ggplot, but it has better control and formatting and less line of coding to achieve nice and publication ready plots. So if you search ggpub-r in Google, so it makes these kind of plots, and it also provide different color scheme by publication and journal types. Like you can have Nature Publishing Group or Springer or ACS or other medical journals and so on. So that's why ggpub-r is actually a handy package to making plots in R. Yeah. Okay. So there are several other plotting packages in R. So ggplot2 is one of the basic one. Then there are spatial one, like you have violin plot, you have Venn diagram packages, and you need to search on Google trying to find these packages for spatial graphics. ggpubr covers several of the basic plots. Which of them it's covering, you can go to package list and click on ggpubr here, and then after this gg you will see this list of plots. So here we see it can create balloon plot, bar, box, density, donut, dot, histogram, line, and pie, violin. So ggpubr provide pretty decent list of commonly used graphics that we need to make for publications and presentations. I will cover some of the basic plot like a line chart, a bar chart, and box and whisker plot, and a scatter plot too. So we will look at 4 plots quickly. My goal is to give you a simple idea that how plotting works in R, how do you create a data frame for it, and how you can modify basic graphics properties like color or grouping. But ggpubr provides excellent, let's say, bar plot. Yeah, examples. So if you go to a plot documentation, it provides these examples. I'm actually using this example in my code too, but I'm just taking the first 2-3 examples. But you can play with all of these examples. You can run them and then try to get an idea that what is happening. So for example, here adding error bar. And so if you run this code, it will add an error bar. These are useful things that you will need to do it for your publications or for your manuscripts. And all these examples you can explore in your free time. But let's cover some of the basic one. So in order to use ggpubr, you need to first install it. That's the command for it. Install.packages ggpubr in quotation mark. Once you have it, in order to load it, you call it by library ggpubr. And library ggpubr will load all the functions in our memory for ggpubr package. Now for bar plot, I'm using the same data from here. So if you are in your RStudio console, you can actually copy this code from here with me, and it will create those plot in your RStudio software. So let's copy this one. It's exactly the same code that I have here. It's exactly the same code, but I just selected few examples. I'm not going to go through all of them. So what are we doing here? We making a data frame. As I explained in the first part of the lecture today, it has a vector dose, and vector has 3 values. These are strings because they have quotation around it, and then it has a second vector len, and these are numericals. We can see them. And then print command was just going to display the data frame here. So this data frame has 2 columns, dose and length, and these are 3 values, 0.5, 1 and 2, and 4.2, 10 and 29. Now the basic plot with label outside. So this is the simplest plot, and label outside there means that we have label on top of the bar. So what it did, we have an input data frame, then we need to provide what's on the x-axis, and in the quotation you need to provide the name of the column. So we want to have x-axis dose, so that's dose here on the x-axis. Then the y-axis we want to have lane, and that's lane on the y-axis. The labels you want to have true, that yes, we want to have a label on the data. So if you make it false, label will go away. You see there is no label, but sometimes it's helpful to show the labels. Label positions, it's out that it's on top of the plot. Now that's a really basic plot. Now you can think about that, yeah, I want to have a label in, or there could be many parameters instead of out. You need to look at the documentation that what are other options, like can I have in, or can I have like on the left side or right side, or how far I can have the label on top. These are all customization that you can play with, but that's how you use it. You have a function ggbar plot, it takes an input data frame, then you need to provide the name of the column on the x-axis, name of the column for the y-axis, and then for this plot, if you want to have label true, and the position of the label. Now, several times you say, I don't like the order that it's 0.5, I want to start with D2. So D2 should be on this side. So for that customization, ggbar plot provides you call an order vector. It takes order as a vector, and then in this vector you provide that exactly what order you want. If you say D2 should be first, D1 should be second, and D05 should be the third one, and then it will switch the order. You will need this several times, because by default R uses the alphabetical and numerical sorting whenever you have x-axis values, and which can be annoying several times, because when you're importing data or when you were generating data, you probably didn't use the alphabetical sorting order, and so you can provide more meaningful order for the x-axis in this order parameter. Now if you have two groups, so for two groups we create other data frame, and we have a dose len, and we say this data other column called sub. So we have a third column called sub, and that has two values, VC and OZ. And we want to have x-axis same as this plot, but we want to have second group change color by a second group sub. So basically you take the column and you split it in two. So that's a stacked bar plot, that how many are from subgroup and how many are from VC group. Change position. So instead of having stacked, you can have two columns next to each other for each categorical variable, like DO5, this is sub and this is VC group. Now these are all basic examples, but they're already looking nice. I didn't do much optimization, I just took the example data. As long as your data frame is in this format, it doesn't look that complicated, that it's only like 3 columns and simple values. So if you can import your data, or you can create your data in Excel and then import that Excel sheet directly in R, and then you can use this ggbar plot command directly on data created in Excel. That would be a home exercise for you. So that was bar plot, and what parameters you see here, it's called palette. Here palette is a color scheme. So it says paired, but if you say NPG, then what it does, it takes sort of like a Nature Publishing Group. So what kind of coloring scheme Nature Publishing Group like? On ggpub.r website, you can find a list of coloring scheme. So you don't need to think about that I want to have it blue or red or yellow and thing. You just use the coloring scheme by publication type. And this is helpful because many times we don't know what is the best coloring scheme, and so this palette parameter is handy, really handy. Others are intuitive, like label true false, label color should be white, label position should be in, that we have inside the column. Yeah, into these two commands, we're basically telling that x-axis and y-axis are same as the basic plot, but do the filling by sub and the colors of the stack bars should be by sub, and then palette should be NPG. Line chart. So we create other data frame. It's exactly the same, and we provide x-axis dose and y-axis len. It's basically the same bar chart, but instead of having a bar, we have a line. That we have 1, 2, 3, and there is a dot there. Now, ggpub.r do provide you to put error bars, spot the outlier, or put a line, all that parameters that you can look at the documentation. You will find all those parameters, and there is a code for that, and you can use that code directly for your data. Multiple group line plot, and so now we have line type as a grouping parameter, that it should be sub, and so we have two line. The dotted line is VC, and hard line is sub OJ, and the shape are different. So if you don't provide the shape, both will be the same type. So you have both squares, and if you provide the shape parameter, it will try to find, like one is a triangle and other is a diamond here. You can change colors of the line, and so here palette, in this command, it's using palette, that it's this particular color I want to have for the first line and this one for the second line. And so I could actually change the color to red and white. No, not white. White will not be this visible. So now we have one line is red and other is black. You can change any color you like. It's pretty flexible here, and all you have to understand is that the palette input is a vector here. It should be exactly the same number of grouping variable, so you need to provide same number of colors. And if you type question mark GG line, then you will get all these different examples here. So I just took the first two, and then what it's doing is importing other data frame. Then it will show that how to visualize mean, how to put a mean standard error bar, and how do you add jitters, how do you add dot and error bar, and how do you add violin and errors, and how do you make line plot with multiple groups and error bars. So these are great examples, but I cannot cover them all in this tutorial. My idea is to give you a basic example of top couple of them, and then let you play with these example data, and then try to explore these different options. All you have to do is understand the documentation. So documentation is pretty detailed. So for example, palette, you can see It explains that you can have NPG, American Association of Science, Lancet, JCO, and so on. And if you Google it, you will find several other palettes as well. So a scatter plot, one new thing to learn about it, that there is a function called data, just data, and it takes input a name of a data. So what did a data function does? What data function expects that when you start the R software, RStudio software, and you load a package can have functions, but it can also have data, and these data could be test data. So R provides you some inbuilt test data, and empty cars is one of those test data that are already in R. When you open the R software, these data are already loaded. So when you say data empty cars, so we get a variables empty cars here, which means we can use empty cars data. And we assign empty cars to other variables called df, and now we can say df, we examine it, and so we can see the top rows, that what are this. So these are car names and some details about how these car are in terms of like miles per gallon, cylinders, horsepower, and weight, how many gears it has, what's a carburetor, and so on. So these are different kind of cars and values of their mechanical or machine properties. So for this scatter plot example data, we convert cylinder to factor, and then we look at that we have weight, MPG, and cylinder, head command, and so what we did, it's a lot of thing in one line of code, one function call. So we take a data frame input for GZ scatter function. X-axis is weight, Y-axis is MPG, then color of the dot will be black, shape is 21, which is empty circle, size is 3, you can make it smaller and bigger. Add regression line, so that is a cool means that you don't need to calculate regression parameter outside. It will do the regression analysis just by adding this line, add regression lines. Then you can customize the regression line by color blue or fill light gray. So that is the confidence interval. And then we can add confidence interval true, and we can add correlation coefficient true, and we can also customize that what correlation coefficients you want to have. So the method is Pearson. You can have Spearman, you have Condal, you can have mu. We covered that yesterday, that you can compute correlation with different matrices. You can type that. And label.x, this is the location of the label, that how far you want to have label on the plot. And label should be separated by an enter. So R and then enter and put the p-value in the next line. Now this is pretty handy plotting option, that you can do a lot of things and to make a publication ready plot, that you have X and Y axis, you did the correlation, you got the regression, you put the p-value, you also put the R-square value on it. What it shows that ggpubr package, it's pretty powerful in making these publication ready plots. And then instead of so we added the regression line, which is a Pearson coefficient, but you can also add a lowest line, which is the other way to do regression, which is non-parametric regression, that instead of fitting a linear line, you can fit a non-linear line. Now, the third option is that if you want to change the size of the dot by other variable. So I don't know what the QSEC mean, but it's using QSEC as a size parameter. So then we can see the size of the dot is according to QSEC values, that the highest is 22.5 and the lowest is 15, and that's how it looks. So that's sort of a bubble plot, that each dot is and then we have different dots with different sizes. You can use a categorical vector as a color and then provide a color palette, and that way you can color different dots by a categorical variable. In this case it's cylinder, and we can see that all these 4-cylinder vehicles are here, and all the 8-cylinder vehicle are here, and 6-cylinder vehicle are in between. And then it goes into a little more sophistication, that you can put circles around these categorical responses. So here we take, so basically this part is up to here, and then we added ellipse, which these are the circles, and we can say mean point true and star plots true, which is showing that there is a mean here, and these star basically showing the difference from the mean for each dot, and the circle showing how much expected spread of that group is. So we can see that the range of cylinder 4 is this, and range of cylinder 8 is this. And these plots are helpful when you're making a PCA plot and you have a knockout like condition A and condition B, and you want to draw a circle on 2 experimental group. So you can think of that way, that in your PCA, if you want to add this ellipse plot and put and circle them. You can put labels on each dot and then use the option repel to get rid of overlapping. So what we did is we first provided names, row names for the data frame, and then we use a command called parameter called label name, and the repel is true. What repel does, it put these lines to get rid of the overlap. So you see these lines? Because if you put this name right here, you can't read it. So repel is helpful to get rid of overlaps when you're plotting a lot of data in single plot. So the last plot is box and whisker plot. We will get other data called tooth growth, save it as a data frame, and we will call GG box plot. Simple, that X should be dose, Y should be lane, and the width of the box is 0.8. We add dot plot, and it will show all the values in this nice way, that what is the spread, where the values are, sort of a distribution, that okay, we have a lot of values in between here and some of them are outlier. Instead of having them organized this way, we can have a simple jitter one, that it's randomly put these values as jitter. We can fill the box that we want to have border as black and the fill as gray. Or we can combine the fill and the jitter both together. So we can have add jitter color by classes and shape by those. So you can have circles here, diamonds in middle, and the squares at the third part. Now this is going into really into a like art, that what is, do we need to have multiple color and shapes and different size in one box and whisker plot. I would recommend you, if you don't need to use colors, don't use it. Just go with the shapes. Shapes are better because when you print it, you can discriminate it on a black and white picture. Then if you have two groups, then you provide them as a color sub, and it will split into two box and whisker plot. So you can think of that if you have a knockout experiment, you have one genotype and other genotype, and then they were given the same dose, so you can see the dose response for two knockouts. You can visualize in that way. So that's all for good plotting. So I covered data frames, I covered how do you play with the data frame and some key functions for that, and how to use basic plotting functions using ggpubart package. So this is the end of the tutorial here. There's some pending topic that I wanted to cover, but couldn't fit into the timeline. I will try to make some YouTube videos for those, like making your own function, applying functional vectors, how to play with data matrices, and some other statistical analysis on like a real world experimental data. I will not have live stream videos for that, but I will try to put those videos directly on YouTube. So with that, I want to end this, and thank you for watching it. Hope you learn the basics of R, and you will be able to import your data in R and do something great with this. Thank you all. Thanks.